Alrighty, we're going to try and go over chapter 4 in 5 minutes. I haven't tried this yet. We'll see if this works. Okay, so 5 minutes on the clock. Here we go, all of chapter 4. My screen's on. Okay, similar figures. Similar figures are figures that have the same shape, right, but not the same size. So you're looking at either shrinking it or enlarging it. And what's great about it is there's always a ratio of what is your multiplier, right? So from here, if you're going bigger to smaller, you're still multiplying, but like by half. It is half the size. It is a quarter of the size. Or if you're getting bigger, then it's twice the size, 3 times the size, 4 times the size, 5 times the size. And what's great about it is that every single side or every single part is enlarged at the same rate, at that same multiplier, or else it would like look really weird. Scale drawings, same thing, but you're looking at different types of drawings. So it could be an object, it could be what they use for architects when they have the blueprints and stuff like that. So same thing, and when you're looking at that ratio, that is your multiplier as well. Recognizing proportional relationships. There are multiple ways that you can see if it's proportional. First way is a graph. It's going to go through that again, right? But the graph, it has to be a straight line. It has to go through the origin, which is 0, 0. So for this one, 0, straight line. Here, not proportional because it does not go through 0. 0 is right there. This one, not proportional because it's not a straight line. This is curved, right? The table, we're looking at this. It's the same ratio every single time. What ratio means is you put one number over the other. Usually we do y over x, but this example shows x over y, and that's okay, right? So 2 over 6 and 6 over 18, when you divide those or when you simplify those, it's the same thing. Here on this one, not proportional. You can see that it doesn't go through 0, 0 either, right? But 2 over 10, that equals 1/5. This one, 6 over 22, that equals 3 over 11. It does not simplify to the same fraction. It does not equal the same decimal. From an equation, your format is y equals kx, which means that k is that constant. It's that multiplier, right? So whatever you have, you multiply by that number, and it's the same rate every single time. What it would not look like for not proportional is if there's like a +2, +3, anything outside of that. And then the situation, looking at it, you're having that constant rate. So a CD costs $1.75 every single time. It's not going to get cheaper. It's not going to get more expensive. I get paid a certain amount every single hour. It's not going to make more money. I'm not going to make less money. It's the same rate. Same thing with tables and graphs. Again, same ratios, straight line through the origin. Right? Unit rate and proportional equations. Looking at the unit rate, to find the unit rate, you're looking for 1. Unit means 1. So you just divide by how many there are, right? If I buy some soda water, then I divide that price by how many cans of soda water there are to find the price for 1. I love this one because it helps me find the cheapest rate. Connecting it as a web. This is our constant of proportionality, our multiplier. This is our equation, our y equals kx, or they have different letters, right? The table, the graph is here. It's proportional because 0, 0, and straight line. And then the situation, 2 cubic yards each hour, every hour, per hour. Those are the key words that you want to use to know that it's proportional, right? And knowing that each one of these are interchanged and telling the same story. Combining like terms. You can only combine terms that are alike, meaning x squared, how it's a different shape and a different color in this situation. You can combine those together, but you cannot combine them with the ones, right? So here I can combine my ones together. I combine my x's together. There's 2 of them, so 2 x's. Here there are 3 x squareds, and that's all I can do. So 3 x squareds, 2 x's, and then there's 4 of the single ones. Distributive property, whatever's on the outside of the parentheses, you have to multiply it, right? There's no symbol right there, but it's multiply to everything in the parentheses, right? This means 3 sets of 2 tacos and a soda, which means I get 2 tacos and a soda, my sister gets 2 tacos and a soda, and then my dog gets 2 tacos and a soda, and that's what it equals, right? Noticing that you cannot combine these. You cannot combine because they are different variables. This is tacos, this is drinks. You cannot make taco drinks. Don't blend it together. That's nasty. Simplifying with 0, this is the last one. Looking at this, if you have positives and negatives, you can make zeros with those, but everything else, you got to make sure that you combine the correct things, right? So my x's and my y's, you cannot combine those together. My ones and my negative ones, yeah, we can make 0 pairs with that. And that's how we simplify our fractions, or not fractions, our expressions. That's it. Thanks.